Hello, this starts the video about graphs of absolute value functions. In class, we explored some graphs of absolute value functions. So just want to remind you that the graphs of absolute value functions, of absolute value linear functions, are in the shape of a V. So we're going to look at the absolute value of x again as a function, and we're going to graph that over here at the right. So I can make a table and, plug in our standard inputs, and then we will graph those. So if I'm looking at f of -3, absolute value of -3 is +3. So -3, +3, right, that point. And -2, absolute value of -2 is +2. So input of -2 has an output of +2, and so on and so forth down that table. And if I plot those points, that is where we end up. If I graph those, we see that V, we see that vertex, and there is one side of the V, and here is the other. Looks a little shifted over, but my vertex is at 0, 0 right there. So let me erase this table that we don't need that. And if I want to solve f of x equals 2, what is that asking me? Okay, well, solve means, generally speaking, I want to find out what is x equal to. X is not 2. F of x is 2. So that means the output is 2. And output is on the y-axis. So I'm looking at, here's the y being 2. Along that red line is all the points where y is 2. So I want to know specifically, when is my absolute value function, that green, equal to 2? Well, at 2 points. At -2 and at +2. So we say the solutions, because these are x values, we write this in solution set notation, is -2 and +2. So if I look down at those, if I look at my graph, when my output is +2, the input that goes with that is down on the x-axis at -2 and +2. So my solution set is -2, +2. Okay, so let me erase that line. Okay, now that we've got that y equals 2 or f of x equals 2 red line off of there, let's take a look at solving f of x equals 0. So again, we're wanting to solve, so we want to find out the x's when the output is 0, when the y is 0. So where is y equal to 0? Right along that x-axis. And the only point that has an output of 0 is when the input is also 0, which makes sense. We're saying when x is 0, f of 0 does equal 0. That checks. Okay. So let's get rid of that line. And think about when solving f of x is equal to -2. Well, -2 is right there. When does my function equal -2? Never. That function is always positive. F of x equal to the absolute value of x is always positive in this case. So there is no solution. There is no x that you can put in to get out a -2. So no solution. So let's think in what this tells us in general about absolute value functions. So if we're looking just specifically about the absolute value of x, so the basic parent function of absolute values, and p is a positive number, the solution when the absolute value of x is equal to that positive number, for example, like above, we had +2, are the numbers -2 and +2. So instead of being specific to 2, +2, we're just saying any positive number. So imagine we had talked about 4. When is f of x equal to 4? When is the absolute value of x equal to 4? Well, that would be at -4 and +4. So in general, we are talking about -p or +p. So the absolute value of x being equal to p could be -p or +p. When is the absolute value of x equal to 0? Only at 0. When is the absolute value of x equal to negative number? So -p means the opposite of a positive number, a negative number. When can the absolute value be negative? Never. So we say no solution. The equation, the absolute value of x equal to negative number, has no solution. So let's give you one to practice. What I'd like for you to do is to graph f of x equal to negative of the absolute value of x minus 3. So you can do this with a t-table, or you can also go into Desmos or some graphing technology and graph that, sketch the graph accurately in the space provided, and then I want you to solve for x, right? What x values make f of x equal to -3? When is f of x equal to 0? And when is f of x equal to +3? And remember to write your solutions in set notation.